Next, we're going to look at symmetry. Remember, symmetry means the same. We have line symmetry. So if it's symmetric with the x-axis, that means your graph is going to be the same above it and below it. That is, every point has a y value and the opposite of y value with it. When I look at it algebraically, if I replace y with negative y, I get the same equation. When I look at respect with the y-axis, that means for every y value I have the x value and its opposite, or they're going to exist. So I can look at it, it's symmetric with the y-axis. When I do that, I replace x with negative x, I get an equivalent equation. Now then we also have point symmetry, which means 180-degree rotation. So it has rotational symmetry. So in other words, for every point I have in my graph, I have the opposite point on my graph. So I replace both x with negative x and y with negative y, and then I get the equivalent equation. That's how we test it algebraically. So let's take a look here. On our problem, on our next example, I want to use the graph of the equation to test for symmetry with respect to the x-axis, the y-axis, and the origin. And then I want to support my answers numerically and confirm them algebraically. So first off, when I look at this first example, it seems to me it's symmetric with the y-axis. Since it's symmetric with the y-axis, I can replace one of my numbers, or let's replace x with negative x. So in other words, y equals the opposite of x squared plus 2. Well, the opposite of x squared, that's x squared plus 2, isn't it? So that equals the same. You see how my two functions are the same? So that means it's symmetric with the y-axis. Then if I look at example 7, it doesn't seem to be symmetric with the y-axis because I don't have a point corresponding to the other side of the y. It doesn't seem to be symmetric with the x-axis because I don't have if I have a point, I don't have a point on the opposite side of the x-axis. But it does seem like it's symmetric with the origin because for every point I have the opposite point on the other side. So it seems like we have point symmetry here. So I'm going to say it's symmetric respect to the origin. Now let's check. That means I'm going to replace x with negative x and y with negative y. So I have negative x, or the opposite of x, times the opposite of y, that equals to negative 6. If I take negative x times negative y, negative times the negative is a positive, so I get xy equals negative 6. Notice these two equations are the same, aren't they? So it is symmetric with respect to the origin.